Now we need to talk about another protocol called Dynamic Host Configuration Protocol, DHCP. The DHCP, the Dynamic Host Configuration Protocol, is a network management protocol used on IP networks for assigning IP addresses and other parameters to devices connected to the network using a typical client-server architecture. The technology, the DHCP protocol and the PCs, the client-server architecture, eliminates the need for individually configuring network devices manually and consists of two network components: a centrally installed network DHCP server and client instances of the protocol stack on each computer or device. When connected to the network and periodically thereafter, the client requests a set of parameters from DHCP server using the DHCP protocol. The DHCP services exist for networks running IP version 4 as well as version 6. And the version 6 of DHCP is commonly called DHCP version 6. The DHCP protocol is defined in the RFC 2131 and use two ports in the DHCP protocol run over UDP, over the user datagram protocol, and use the port 67 in the side of the server and 68 in the side of the client. The DHCP server can automatically assign several parameters, not only IP address, but and net mask, but the gateway or next hop for the default route, the DNS server, and other parameters. The DHCP is based on the former BootP protocol, and DHCP employ a connectionless service model, and the DHCP operations fall into four phases: server discovery, IP lease offer, IP lease request, and IP lease acknowledgement. These stages are often abbreviated as DORA, D-O-R-I, yes, for discovery, offer, request, and acknowledgement. And the DHCP operation begins with clients broadcasting a request. If the client and server are in different broadcast domain, a DHCP helper or DHCP relay agent may be used. And the clients requesting renewal of an existing lease may communicate directly via UDP unicast, since the client already has an established IP address at that point. Here we are, a brief figure that illustrates all the information related with the DHCP protocol. That is, its client-server architecture. The server listen the clients into the port 67 of UDP. The client use the port 68 always. Remember, DHCP runs over UDP, that is the message. The DHCP protocol data unit is encapsulated into the UDP datagram. When the DHCP client requests an IP address to DHCP server, the DHCP server answer the request with several parameters, typically not only the IP address that the client use and the mask that the DHCP use in the interface, the network interface, but the default gateway and the DNS server of the client side. Then here we are, the different phases of operation. When, for instance, the typical hosts that need an address broadcast DHCP discover in order to locate a server. If one or more DHCP server listen this broadcast, they could answer offering configuration parameters to the hosts. If the host receive more than one offer, the host could choose one of those offers, and in that case, the host send a DHCP request to the server, choose requesting offered parameters from that server. Finally, the DHCP server answer or confirm the assignation with the DHCP acknowledge. Here we are, another protocol exchange that shows, for instance, that when the client broadcasts to discover, more than one server could receive the broadcast, the DHCP discover, and both servers could answer to the client with the offered parameters. Then the client choose, for instance, if the client will use the parameters offered by one server or the other. Then the client send a DHCP request to the server chosen. And finally, the server chosen, when received the DHCP request, confirm the configuration with the DHCP acknowledge. Another details to be taken into account is the DHCP use what is called a lease time. The lease time is the time that the host could use the assigned address and other parameters. The DHCP, the lease time, is specified in the DHCP acknowledge when the DHCP server confirm the assignation. When a DHCP client refreshes an assignment, it initially requests the same parameter values, but the DHCP server may assign a new address on the assignment policy set by based on the assignment policy set by administrators. That is, if the lease time is close to timeout, then the host could renew the refresh the assignation. But in that case, the DHCP server could reject the same parameters and assign new parameters. In the case of, for instance, if a host is mobile, for instance, a host that is attached across, for instance, a Wi-Fi zone, or is plugged in another port that is in another subnetwork. That is typical case of network change. The host already has an IP address, and when reconnected to the network with typically a DHCP request, it requests the renewal of the lease with the DHCP request, but the IP address is no longer valid in that network. Then, for instance, in that case, the DHCP server could respond the DHCP request with the DHCP NAC instead of respond with a NAC, DHCP ACK. And in that way, the DHCP, the host need to resend a DHCP request, and in that case, the server will confirm the new assignation. Finally, client the host could use a DHCP release in order to indicate to the DHCP server that the network address is no longer needed, and canceling the remaining list, and in that way the DHCP server could use that address release. This is typically the format of the DHCP message or DHCP view. Remember, this message, this DHCP message is encapsulated in the payload of the UDP datagram. And then there are several fields. Those fields are typically the opcode, for instance, or for instance the transaction ID in order to match the responses with the requests, or the client's address assigned, or the IP address of the server, or for instance, if we use a relay agent, the address of the relay agent, and for instance, the MAC address of the client, of the host requesting an IP address. And remember, at the end of the DHCP message, there are several options that are coded, and those options are, for instance, the option 53 that specify the message type, the DHCP message type, that is DHCP discovery, DHCP offer, DHCP request, DHCP acknowledge, etc. The option 50 that specify the IP address assigned or offered. The option 1, that is the mask offered or assigned. The option 3, the default gateway specified. The option 4, the time server, the time server for instance the network time protocol, the use of NTP protocol. The option 6 that specify the DNS server that could use the client, the DHCP client, or for instance, typically the option 51 that specify the list time of the IP address offered and assigned. Finally, there are we talk about a little bit about the DHCP relaying. DHCP server can also provide IP addresses for multiple subnets, not only the subnets that are directly connected to the DHCP server, but in that case, the client's broadcast can only be received on its own subnet. Then we need to propagate the DHCP discovery of a client to a remote DHCP server. In order to perform that task, that task, the DHCP relay agent can be installed and configured on these subnets. DHCP relay agent runs on a network device, typically a router, capable of routing between the client subnet and the subnet of the DHCP server. In order to specify which is the subnet where the client is, the DHCP relay agent code his IP address into the into this field GIADDR. And remember that field is this one, the relay agent IP address, or gateway IP address. And then finally, in fact, the communication between the relay agent and the DHCP server is established using the port 67 in both sides. Finally, talking about DHCP, we could talk simply which are the strategies implemented in the DHCP servers in order to allocate addresses. Depending on implementation, the DHCP server may have three methods of allocating IP addresses. One is the typical dynamic allocation, network administration, reserve a range of IP addresses for DHCP, and each DHCP client on the LAN is configured to request an IP address from the DHCP server during network initialization. Or automatic allocation that is slightly similar to dynamic allocation, but the DHCP server keeps the tables of past IP address assignment so that it can preferentially assign to a client the same IP address that the client previously had. And finally, the manual allocation, that is, we could assign statically the same, always the same IP addresses to a particular host that is identified with hardware or hardware address or MAC address.